Hi, good morning, greetings from Lima, Peru. Good afternoon for those in Central European time. I'm Carlos F. Enguix, and I'm presenting this time the activities involved regarding the ORKG grant during the second semester of 2024. Here I present the agenda of this presentation. First, I will introduce myself by indicating what is my personal background, what are my current and past research interests, included the list of comparisons and contributions submitted so far, uh, alongside with some minor general statistics. Next, I will go through the entire list of the diverse comparisons, and finally I'll end up indicating what are my most recent research interests. Now I will tell you what is my personal background. I am an independent senior R&D researcher and an ACM Sigmod member. My education includes a research master by honours in information systems at Wollongong University, New South Wales, Australia. I was a former member of the Knowledge Management Research Group at the School of Information Technologies at the University of Sydney, Australia. I have been also a former member of the Decision Systems Lab, Wollongong University, Australia. I work as a former Word Package leader at the Web Network of Excellence, as a team leader of the World Word Package 2.3 Dynamics versioning of ontologies within the 4-year Network of Excellence project funded by the European Commission 6th Framework. I was a former PhD candidate in information systems at the University of Wollongong and University of Sydney, New South Wales, Australia. I have been a former ACM Computing Reviews reviewer during several years. I have been a holder of several research scholarships and research fellowships. And I worked in the past as a former University Computer Science Information System lecturer at the Mediterranean University of Science and Technology, at the Technical University of Valencia in Spain during several years. My current research interests include the following: semantic web, everything related to the semantic web, such as semantic web-based triple stores, graph databases, RDF, RDFS, OWL, SPARQL, SHACL, etc. Knowledge graphs, I'm particularly interested in open knowledge graphs and personal knowledge graphs. And my last interests include integrating large language models and knowledge graphs, small language models, integrating small language models, and personal knowledge graphs. Among my past research interests, I include World Wide Web database search engines, information retrieval, semantic indexing, clustering algorithms, intelligent agents, and case-based reasoning, and web engineering. During this semester, I have completed 3 comparisons in July, 1 extra large comparison with 71 contributions in August. In September, I have completed 2 comparisons, and in October, I have submitted also a pretty large comparison with 53 contributions. The temporary total contribution so far is 207, and which roughly amounts a total of 52 contributions per month. In my first comparison in July 2024, the comparison was comparison of large language model-based natural language to SPARQL queries, which included in total 6 contributions. These comparisons included the most representative state-of-the-art LLM-based system for natural language to SPARQL queries via the usage of specialized datasets, knowledge graphs, and fine-tuning. We present the following research question associated with the system presented here. Research question 1. Do large language model-based natural language to SPARQL query systems increase accuracy metrics significantly for generating valid SPARQL queries? Research question 2. Do large language model-based natural language to SPARQL systems improve accuracy metrics using specialized data sets and knowledge graphs. And research question 3, can small language models be fine-tuned for converting natural language queries into valid SPARQL queries and achieve accuracy metrics comparable to large language models? My second comparison in July 2024 was comparison of text to SQL benchmarks datasets, which include a total of 5 contributions. This comparison included the most representative state-of-the-art text to SQL benchmarks datasets since 2017. We present the following research questions associated with the systems and benchmarks datasets presented here. 1. Research question 1. Were these systems presented alongside a time frame since 2017 represented state-of-the-art systems in their time? 2. Research question 2. Apart from cross-domain and complex databases and schema linking, can these benchmarks datasets include value comprehension and SQL query execution efficiency? And third, research question 3. Given the large language model hype and large language model state-of-the-art system capabilities, can they serve as a natural language database interface in text-to-SQL systems? My last comparison in July was comparison of state-of-the-art text-to-SQL translation systems with 24 contributions. This comparison included the most representative state-of-the-art natural language text-to-SQL translation system interfaces using large language models. We present the following research questions associated with the systems presented here. Research question 1. Were these systems presented alongside a time frame between 2023 and 2024 represented state-of-the-art systems? Research question 2. What are the common data sets and benchmarks used in these systems? Research question 3. Given large language model state-of-the-art systems, can they serve as efficient and perform a natural language database interfaces in text-to-SQL systems? 4. In August 2024, I completed submitted a comparison that entitled as Retrieval Augmented Generation, Large Language Model Comparison with 71 contributions. This comparison is based on the Retrieval Augmented Generation for Large Language Models survey, which included 71 state-of-the-art retrieval augmented generation for large language model systems, which were analyzed and classified according to different features characteristics, namely retrieval source. The external database source considered, for instance, Wikipedia, search engine, common crawl, dataset, base. Retrieval data type. The type of external data type considered in the retrieval augmented generation system, text, code, knowledge graph, etc. Retrieval granularity, the granularity of the input data, sentence, chunk, document, entity, triplet. Augmentation stage, the large language model stage when the retrieval augmented generation system is applied. Is it applied in pre-training, tuning, inference, etc.? And finally, retrieval process. When the retrieval augmented generation retrieval process is applied and frequency, once, iterative, adaptive, recursive, multi-time. The survey discussed the challenges and advancements in incorporating external noise to enhance the accuracy and credibility of language generation tasks. Large language models face challenges like hallucinations and outdated knowledge. Retrieval augmented generation systems integrate external databases, enhancing accuracy and credibility. We have presented several research questions. Among them is, do retrieval augmented generation systems for large language models avoid hallucinations and have access to recently updated information available when the large language model was trained, which is called informally as the cutoff date? Research question 2. Large language model long context versus retrieval augmented generation. Do large language models context undervalue the benefit of using retrieval augmented generation systems? Research question 3. What are the benefits of retrieval augmented generation systems in large language models? Research question 4. What are the differences between naive retrieval augmented generation, advanced retrieval augmented generation, modular retrieval augmented generation? And finally, research question 5 is modular retrieval augmented generation the current retrieval augmented generation architecture trend? In September 2024, I submitted two comparisons. First one was comparison of large language model hallucination benchmarks with 29 contributions. This comparison included the most representative state-of-the-art large language model hallucination evaluation and detection benchmarks as of the end of 2023. It is based on a survey on hallucinations in large language models, principles, taxonomy, challenges, and open questions, and including each respective benchmark containing or referring 1. Hallucination evaluation benchmarks, which are devised to assess large language models' tendency to produce hallucinations, with a particular emphasis on identifying factual inaccuracies and measuring deviations from original context. 2. Hallucination detection benchmark. Most studies have primarily concentrated on task-specific hallucinations, among them abstractive summarization, data-to-text, and machine translation. Factuality hallucinations in large language models refer to instances where the generated content contains factual inaccuracies, inconsistencies, or fabrications that deviate from reality or established knowledge. These hallucinations can be categorized into two primary types: factual inconsistency, where the output includes contradictory facts; factual fabrications, where the content contains unsupported or fictional information. On the other hand, faithfulness hallucinations in large language models refer to instances where the model's outputs deviates from user instructions or provided contextual information. The second comparison submitted in September 2024 was comparison of applications of personal knowledge graphs, which included 19 contributions. This comparison included 9 overlapping personal knowledge graphs category application types. This classification is one of the main contributions of the following book chapter: Applications of Personal Knowledge Graphs, book chapter of the book Personal Knowledge Graphs Methodologies, Tools, and Applications ebook, including the aforementioned 9 different application types. We presented the following research questions associated with this book chapter. Research question 1. What were the main differences between personal knowledge graphs and personalized knowledge graphs? Research question 2. What are the differences between semantic web stack and label property graph based personal knowledge graphs? Although the seminal paper by Christian Balloch, Personal Knowledge Graphs, a Research Agenda, indicated that neurosymbolic approaches cannot be applied from a general perspective given the lack of training data in personal knowledge graphs. He questioned if neurosymbolic approaches can be applied to personal knowledge graphs and personalized knowledge graphs. In October, I presented the following comparison. The comparison of small language models with 53 contributions. This comparison included a state-of-the-art analysis and statistics of small language models as of October 2024, based on the survey Small Language Models Survey Measurements and Insights, including a detailed table from which I included submitted this comparison. The small language models considered are all of them transformer-based and decoder-only models within the range of 100 million to 5 billion parameters, designed for resource-efficient deployment on devices with constrained hardware requirements. These comparisons analyzes 53 state-of-the-art small language models, focusing on their architectures, trained datasets, and algorithms. The key insights provided in the article, which I recommend to read because it's really interesting for those that you are interested in small language models. First, the first insight was that the typical small language model architecture included group query attention, gated feed-forward networks with CELU activation, also known as switch, a self-gated activation function that combines the advantages of ReLU and sigmoid activation functions. Root means square normalization, and larger vocabulary sizes are becoming standard. Two, the training datasets. Data quality outweighs quantity. Model-based filtering improves dataset quality. Recent small language models are overtrained on large amount of tokens, exceeding the Chinchilla law's recommendations. Among the training algorithms, we can include knowledge distillation. So the small language capabilities. Small language models have shown significant performance improvements from 2022 to 2024, closing the gap with large language models. Larger models generally perform better, but smaller models can excel at specific tasks. Open source datasets are closing the gap with closed source datasets in common sense tasks. In context learning, most small language models benefit from in-context learning, especially in complex tasks. Larger models exhibit stronger in-context learning capabilities. Runtime costs. Model architecture impacts latency, especially during the prefill stage. Quantization benefits are more significant during the decode stage. GPU outperforms CPU significantly in the prefill phase. Context length is crucial for runtime memory usage. This comparison, my seventh comparison submitted to the ORKG, it was submitted to both Medium and LinkedIn as Jupyter notebooks. Here I include the links to access the link to the Medium article, blog post, and in LinkedIn to some large language model related groups. So I end up this presentation with my main current research interests. Among them, I include knowledge graph, closed and open knowledge graphs. Personal knowledge graphs, application of personal knowledge graph accepted as a book chapter at personal knowledge graphs, methodology, tools, and applications. Chapter 2, applications of personal knowledge graph, which I was the main author. Cloud source and open source language models, small language models from a development perspective, submitted as co-author a research paper, text to knowledge graph bench, a benchmark for ontology-driven knowledge graph generation from text, which was accepted at the International Semantic Web Conference 2023 in the conference resource track. And also, what I'm interested in is integrating semantic web-based knowledge graph and large language models, integrating small language models and personal knowledge graph, which I'm currently working on a research paper to be submitted early next year, 2025. So this has been my entire presentation. Thank you very much for your time. I include to both my two emails, so you are able to contact me if you are interested in my research or whatever. I have a website where I include my CV, and I have a personal blog which is under construction. Anyway, thank you very much.